Okay, Algebra 2. This is Unit 2, Day 3 notes. It's all about even and odd functions. Maybe a review. It's been a while since you've seen some of this before. All right, read through this with the reading material. We'll jump right to it. A function is known as even if f of negative x equals f of x. All right, again, lots of notation. Try to keep this all straight. All right, you're not multiplying here. This is just f of x, whatever function you have. F of negative x is everywhere I put a negative x, wherever I see an x. I'll do some examples in a minute. A function is known as odd if f of negative x equals negative f of x. All right, a little bit of notation again. We'll get used to this as we go. You can read through number 1 here. All right, trying to get you to think about what you just wrote down a little bit. All right, some of that makes no sense to some of you, so I'll talk about it again here. All right, so even functions, opposite inputs. Remember, inputs are like your x values. Give the same output. All right, so outputs, I guess. So if you think about it, the negative of some number is the same as that number, all right? So we'll do more examples in a minute, but that's what's going on. If it's an odd function, all right, this is where opposite inputs, all right, give opposite outputs. All right, by the opposite sign, I mean. So a couple different ways to keep these straight. All right, like a fancy textbook definition up here, kind of like basic terms right here. A couple examples in a minute. All right, jumping down to number 2. They give you partial graph of some function f of x. All right, should probably label it. There's f of x. Sketch the other half if it's even, all right, or if it's odd over here. So think about what this is going to look like. If it's even, well, it means opposite inputs have the same output. So let's look at this point like over 3, 1, 2, 3, 4, 5. All right, there's a 0.35. I already counted it out for you. If it has an opposite input, so it means like negative 3, its output's going to be the same. It's going to be 5. All right, this point over here, over 7 down 2, right, or 0.7 negative 2. If I have an opposite input, negative 7, I get the same output, negative 2. 0, 0, that's not going to change much, right? Opposite's the same thing still, so 0, 0 still there. So let's plot these new points. Negative 3, 5 should be on the other side of the y-axis. Right, negative 7, negative 2 should be over here. Connect the dots. We'll assume that's a straight line. Close enough for now. All right, get a picture that looks like this. Just by looking at it, and once you get to know what you're doing, you can say, well, f of x is even. All right, certain things about it. Symmetry, we're going to talk about the next one. Let's finish the odd picture first, though. All right, based on this definition, odd, opposite inputs give opposite outputs. So I think it's the same picture, right? Same points, 0, 0, 3, 5, 7, negative 2. Let's just do the 3, 5, right? So I'm going to do an opposite input, that's negative 3, gives opposite outputs. So instead of 5, it's going to be negative 5. For 7, negative 2, opposite input is still negative 7. The opposite output, though, is positive 2. 0, 0 doesn't change again, that's just what it is. So let's plot these ones, see what it looks like. Negative 3, negative 5, over 3, down 5. All right, kind of small picture, try to count that out. Negative 7 up 2, negative 7 up 2 should be over here. All right, connect them. Close enough. Get an idea what that picture looks like. All right, different pictures. All right, so f of x is even here, f of x is odd over here. Again, probably should label stuff. They don't do that much. Make sure you label things. What do you notice about this one, right? If it's even, what kind of symmetry does it have? All right, this one is even. It is symmetric about the y-axis. All right, so even functions are symmetric about the y-axis. Or symmetric over the y-axis. right? Essentially like a reflection from geometry. How about odd functions? All right, this picture, some of you remember geometry, some of you have no clue what's going on in geometry probably. For odd functions, all right, this one you could say it's symmetrical over the origin. You may have not done too many reflections about the origin, so there's another way to think of that one. Symmetrical about the origin. How about if you take this picture, you flip it upside down, it's still the same picture, right? Same thing. So it's also the same as a rotation of 180, all right? Maybe that's easier to remember. If your picture's the same upside down as it was to start with, it's an odd function. Rotation of 180 degrees. All right, a little geometry for you. Good stuff. All right, odd and even, different ways to name a function, pretty much. Let's do some examples on the back. Number 3, they give you this function. F of x is the absolute value of x minus 4. A couple different parts here. Part A, evaluate this function for a variety of opposite input pairs. Is it odd, even, or neither? All right, let's just think about this. We have basically our function. Let's just pull the table up, right? If you have a calculator, put it in. Let's just do -2 to 0, maybe to +2. All right, if you have a calculator, easy, fill it in. Use brain for a second though. Absolute value makes things positive, then -4. So let's 0 would be the -4. Absolute value of 1 minus 4 is still -3. 2 is -2. All right. How about in the other direction? What's -1? There'll still be 1 minus 4. Still be -3. And -2 would be -2. All right, so that's what a table would look like for this. Off calculator, it'd be easier than thinking about it. Look at a pair of opposite inputs though, like -2 and 2. So those are opposites. What do you notice about the output? Right, the same, right? Same thing for -1, -3. Those are opposite inputs, same output. So opposite input, same output. That means f of x is even. All right. You could say since opposite inputs produce equal outputs. All right, that doesn't really prove it, but it's just a good example to show it. All right. Step B says sketch it. All right, without your calculator, yeah, sure, that's fine. All right, you could sketch it, just plot the points, 0, -4. All right, you know absolute value makes a V shape anyway. Slope is 1, so get the idea, it's a V. Both your V's better than mine, close enough. F of x. All right, does it look like it's even? Yeah, it's symmetrical with the y-axis, right? Symmetrical with the y-axis means if I fold my paper on the y-axis, they line up. It works, it's even, right? So table shows it, picture looks like it's even. We're good to go. Number 4, we'll let you guys try number 4. All right, a little bit more to it. This is x cubed minus 4x. They gave you a table. You can use a calculator if you want. Or just think for a second. Fill in your table. Is it odd, even? Maybe neither, could be neither. And then try to make a sketch of it. All right, you can use your table, just plot some points. Doesn't have to be perfect. We'll go over that one in class the next day. Number 5, let's do number 5 real quick. I got an exponential function, f of x equals 2 to the x. Is it odd, even, or neither? Support your argument with numerical evidence. So we can use some numbers for this one. And maybe you can use a table. You can just pick some random pairs if you wanted to. The table's just as easy. Let's do -2 to 2 again. That works out usually. You can do this in your head though. -2 or +2 to the 0 is just 1. 2 to the first, 2 to the second. We know those top of our head. 2 to the -1st. You should know that one, but you might not. That's 1/2. 2 to the -2 should be 1/4. Remember, negative exponents give you fractions, not negatives. So just by looking at this, all right, looking at opposite pairs here, I have the opposite input, -2 and 2, 4 and 1/4. All right, they're kind of similar, but are they opposites? No, one has to be -4 or +4 to be opposites. They're not the same, clearly, so this is neither. Right, support it with argument, yeah, we did that. You could write down an explanation too, but right now they are neither, that's fine. All right, short and sweet, I think that's the end of the notes. Day 3 homework, more practice. This chart on the homework will make you think a little bit, all right? It tells you they're even. Go back to the definition, what does even mean, what does odd mean, to fill that chart in. All right, pictures like we did before. A little bit of thinking for this one. Good luck.